So this is the study guide for Cumulative Part A number 3. And I'm going to record this. I'm going to try and see if I can do two different videos so I can upload Part 1 and Part 2. Yes? All right, here we go. Let's start with number 1. Everybody on number 1? Make sure you write your name, date, period on that packet, please. And I'm going to zoom in. So now let me show you first, look up please. Let me show you first the mistake that most of you make on this one. Look up. Some of you already know that 5 times negative 3 is negative 15, is that correct? But some of you start at 0, and then all of a sudden you go 1, 2, 3, 4, 5, and you keep going all the way to negative 15. This is incorrect. Does everybody understand that? And let me show you why. What's the factor inside of the parenthesis? Negative 3. So my first jump from 0 has to be to negative 3. And every jump has to be of negative 3. So if it's a negative, it's going to the left, and negative 3, which is that whole jump. And then the factor outside tells me how many times I repeat that. How many times is that? 5. So this is 1, 2, 3, 4. Let me scoot this over. And 5. And that's how we land on negative 15. I want that boxed, and I also want you to write it somewhere where it's visible. Okay? Okay, let's go to number 2. Very simple, yes? Okay, let's go to number 2. Number 2. This one is another one that's coming back, and it talks about income. It doesn't matter what the situation is. In this case, it says a video game store, or it could be, I don't know, that they sell Pokemons, or I don't know. It could be any situation. But whenever something is received, make sure you label that a positive, and whenever something is sold is a negative, because they're talking about things that are coming into the store and out of the store. Okay? So with that said, the easiest way to do these, you're going to add all the positives down here. So what is 0 plus 1? 0 plus 9, that's 10, carry 1. That's 6, 10, that's 13. Now we're going to add all of these, and these are going to be labeled negative. So 5 plus 5 plus 1, that's 11, carry 1. That's 2, 3, 8, 9. And this is a what? A negative. And what are we going to do with these two? We're going to add those two. Okay? But since they are opposite signs, we're going to subtract basically. So it's 130 minus 91. So therefore, we can't take away from here. I'm going to borrow 10 from here. So that is 9, and that is 3. So therefore, we end up with 39 video games in the store. Pretty simple? Once again, just straight down for all positives, straight down for all negatives, and at the end you just combine. Okay? Let's go to number 3. I'm going to zoom in on this one. It says simplify. So check this out. Whenever you get to these that there are 2 parentheses, that means that there's 2 expressions. I want you to do this. Look up, please. Draw a line down. So like that you can know that this you're going to do first, this you're going to do second. And wherever you draw the line down, I want you to put up multiplication signs, because that's what the parentheses indicate. Does that make sense? Yeah, right? Right, Zoe? All right. Focus, please. So we distribute the exponents to exponents. So n to the second times n to the negative 2 becomes n to the negative 4. N to the negative second times negative second, that becomes positive 4. So far so good? All right, so we're done with this expression. Now we're moving on to this one. Same thing. We distribute the negative 3, so that's m. Negative 2 times negative 3, that's positive 6. n. Negative 3 times 2, that's negative 6. Alright? So at that point, check this out. Since we're still multiplying, do you guys see this multiplication sign, and there's invisible multiplication signs here? That means we're going to focus on the same basis. So this is m, and then you circle the exponent, and right here, since it's multiplication, you're going to put a plus, so then you know that you're adding exponents. So what is negative 4 plus 6? Positive 2. That is correct. Then you see the next same base. Since we're multiplying, we're going to add the exponents. 4 plus negative 6, that's negative 2. So far, so good. All right. But what do we know about negative exponents? We cannot have an expression with negative exponents because then it's not simplified. So therefore, first thing you do, you get this one, bring it to the denominator, and change the exponent to a positive, and this one stays in the numerator. And we're done. Yes? Yes, Mr. Q. All right, good. Let's do another one of these on your scratch paper. Label it example 3Q. Example 3Q. Parentheses, x to the third, y to the negative fourth, close parentheses, to the negative, give me a number, 3, okay, times x to the negative, okay, 4, n, oh, I'm sorry, not n, y to the fifth, and all that to the negative 2. See how can you do with that one, please? Go. Okay, let's see. See what we got. First thing you did something like this, and then you put a multiplication sign. You distribute the exponent. This is x to the negative 9, y to the positive 12. Hands if you got that so far. Okay? Next, we distribute these two. That becomes x to the positive 8, y to the negative 10. So far, so good? Then we identify the same basis. We circle the exponents, and above the multiplication, I put a plus because we need to add the exponent. So this becomes x to the negative 1. From there, y and y. Same thing, 12 plus negative 10, that's positive 2. So far, so good? All right. However, can we end up with a negative exponent? No. So at that point, you identify the negative exponent, and you bring that to the denominator and change it to a positive, and this one stays in the numerator, and we're done. Hands if you got that. Bam! All right, let's move on. Go to number 4. All right, so this one, just checking. This one right here, pay attention please, is very similar to the one we just did. So I need you once again to draw a line down and then put a little multiplication sign so that you know that it's two expressions in one. Agree with me? Now, the one mistake that most of you did last time, look up please, you forgot to put an exponent of 1 on everything that did not have an exponent. So that's the first thing you should do. Does that make sense? Because then you forget to distribute the exponent to the number. Okay? So here we go. Let's start with this one. 4 times 1, so that becomes 2 to the 4th. 4 times 1, that's d to the 4th. And 4 times 5, that's e to the 20th. We're done with that one. Let's move on to the next one. You distribute the 6, d to the 6, e to the 6. How are we doing? All right. Let's simplify the number first. This one, write it with small numbers underneath. 2 times 2 times 2 times 2. Because some of you are still doing this. Some of you still think 2 times 4 and you write 8. That is not the case. This is 2 times 2 times 2 times 2, which is 16. And since we're still multiplying, you identify the same basis, which is D. You circle the exponent, and above the multiplication sign, you're going to put a plus. So that becomes 10. Same thing with E. 20 plus 6, 26, and we're done. How are we doing with that one? Okay? Do we need another one of these or no? Okay. Let's go to number 5. Scientific notation. So there are 5.02 times 10 to the 22nd atoms in 1 gram. But here they want us to find out how many in 500 grams. So it's kind of like this. Look up, please. Let's say, how much is it to buy 2 Jack in the Box tacos? $1.07, something like that, right? With tax. But how much is it to buy 500? What do I need to do? Multiply. So that's why, look up please, that's why we need to write this one first. We write 5.02 times 10 to the 22nd. That's only for 1, but they want us to find out how much is it for how many? 500. Now I covered scientific notation, didn't I? Now for those of you that forgot, here it goes. Scientific notation needs to look like this. Now, what I'm going to write right now on top has nothing to do with what we're doing here, but it's just explaining scientific notation. Explaining. Sorry. So, scientific notation should look something like this. 2.3985 times 10 to the, 9. It needs to have only 1 digit on the left side, and it needs to be multiplied times base 10 and an exponent here. Now look at the 500. Is this scientific notation? No, we need to change this. So how do we change it? So here we go. To change this, we need to identify where the decimal is at. The invisible decimal is right there, which means I'm going to move it 2 times. So this becomes 5.00 times 10. Since I moved it twice to the left, I put a 2 right there. Once I got that, I bring my other number down, 5.02 times 10 to the 22nd. So, at this point, we identify same basis. Isn't this the same as this? So then we write 10. And since we're multiplying, what happens to the exponents? We add. So what is 22 plus 2? 24. We write our multiplication sign right there. But now we need to focus on the numbers. We need to multiply this number times this number. So let's see. 5.02 times 5. What is 5 times 2? 10. Carry 1. 5 times 0, 0. Bring down the 1. 5 times 5, that's 25, so this is 25.10. Is this scientific notation? Why not? Tell your neighbor, please. Thank you, Katie. No? Okay. Just kidding, Marissa. Thank you very much. Appreciate it. All right, here we go. Because we only need 1 digit on the left side, so we need to move this one once, which means we add 1 to the exponent here, so this becomes 2.510 times 10 to the 25th. And it says to write in scientific notation, if necessary, round to the nearest 2 decimals. So what would be 2 decimal points for this one? 2.51 times 10 to the 25th. And that's our solution. Yes? Okay, example 5Q. Example 5Q. Do this one by yourself, please. There are 2.62 times 10 to the 22nd atoms in 1 gram of sodium. Did everybody write down the 2.62? But they want us to find out how many atoms in 500 grams. Isn't that about the same? Let me change this. Okay, 800 grams. Very good. So, see if you can do that one by yourself, please. Go. I'll give you some time. And we're going to check for 800 grams. 800 grams. As you're finishing up, let me start writing out the steps. Here we go. 2.62 times 10 to the 22nd times 800. But we need to change 800 to scientific notation, so I move the decimal twice. So this is 8.00 times 10 to the second, because I move the decimal twice. I bring this down. 2.62 times 10 to the 22nd. From there, I identify same bases. These are the same. And I add the exponents. So that becomes to the 24th times. And now I just need to multiply this one times this one. And that goes here. So this is 2.62 times 8, 16. That's 48 plus 1, that's 49. I got 4. 16 plus 4, that's 20. So this is 20.96. Hands if you got up to right there so far. All right? But is that scientific notation? No. Therefore, I move the decimal once. This becomes 20.096 times 10 to the 25th. However, I'm not done because they want us to round it to the nearest 2 decimals. So the 9 becomes a what? A 0, and this one becomes a 1. So this is 2.10 times 10 to the 25th. Hands if you got that by yourself. Okay? Some of you might have forgotten this last step, so make sure you do the last step. Okay? Okay, let's go to number 6. Okay. Look up, please. Whenever you get to these, like what we did earlier on the previous problems, make sure you add an exponent of 1 on anything that does not have an exponent. Everybody with me? So, with that said, look up, please. Since now we have 2 parts, we have a numerator and denominator. I want you to draw a line like this so that you know it's going to continue a fraction over here. So I'm going to work first on the numerator. So then I distribute this times this. This becomes 3 to the second and m to the 18th. So far so good? We do the same for the denominator. Distribute to the denominator. This becomes m to the 12 and to the 9. So let's simplify the number first. This right above it, write out, yes. What's that? Oh yeah, I did that to see if you were paying attention. Be nice. 2 times 9 is 18. Alright, thank you. So, right above this, let's write out the factors. This means what? 3 times 3. What is 3 times 3? 9. So we're done with simplifying the numbers. Now here, this next part, I want you to box the same bases. This one with this one. Since we're dividing, what happens to the exponents? We're going to subtract. So this is m 18 minus 12, that's 6, positive 6. Now look up, please. This is a common mistake that you guys made last time. Some of you wrote this number next to here. That was wrong. Since there are no n's on the numerator, this one stays right here, so we just write n to the 18th in the same spot, and we're done. Let's do another one of these. Example 6q. 6q on your scratch paper. Parentheses, 7x to the 7th over x to the 5th, y to the, give me a number, 12, squared. Go. Do that one by yourself. I'll give you guys 30 seconds. Go. Okay, here we go. First thing you did, I'm pretty sure, you wrote a 1 on the exponent of 7, yes? You drew a line across like this, and you distributed your exponents to the numerator. 7 squared, x to the 14th. You distribute to the denominator, x to the 10th, y to the 24th. So far so good? From there, this became 7 times 7, which is 49. You boxed these. You wrote a subtraction because we're going to subtract the exponent, so this became x to the 4th, and the y to the 24th stays on the denominator, and we're done. Hands if you got that. Okay, good. Michaela, focus. Let's go to number 7. This one. Simplify the expression. So for this one, the first thing we do, we need to rewrite this. So I want you to box 1/3, and then you're going to write cube root, so that you remember that that is that. And what goes inside? 125. So my radicand is 125. So what does this mean? It's saying what number times itself 3 times gives me 125. Everyone? 5. And how do we know that? Because you can start testing it. 1 times 1 times 1, 2 times 2 times 2, till you get to 5 times 5 is 25, times 5 is 125. You bring down the plus sign. There it is. And then we do the same with the next one. Check this out. You circle the exponent, and we know that's a square root. And for those of you that get a little bit confused with these, focus down to, we know that the square root, we don't write the index of 2, is that correct? So therefore, we write the radicand of 25. And what is the square root of 25? 5, so this becomes 10. And we're done. Let's do another one. Example 7q. 7q. Here it goes. 49 to the 1/2 minus 8 to the 1/3. Okay, here goes the process. You boxed or you circled 1/2, that became square root of 49. What is square root of 49? 7. Bring down the subtraction sign. You boxed 1/3, that became cube root of 8. One number times itself 3 times gives us 8. 2. What is 7 minus 2? 5. Hands if you got 5. Bam. Okay, let's move on. Number 8. It says simplify the expression, all variables represent non-negative numbers. So look at this one. This one's very similar to the one we just did. We're just going to focus numbers first, and then we're going to move on to variables. Here we go. So, square root. What is square root of 16? 4. So we're done with this one. You scratch it out. There it is. Next, for the variables, as soon as we get to the variables, look up, I want you to write the index. Write the index so that you remember that you need to divide these, yes? So what is 4 divided by 2? 2, this is a to the second, and we're done with this one. However, this one we cannot divide by 2 because we're going to end up with a decimal, which means we're going to end up again with a radical. So I need to rewrite this. How can I rewrite a 5? 5 becomes 4 plus 1, is that correct? So b to the 5th becomes b to the 4th and b to the 1st inside a radical with the index of 2. So we cross this one out, it became this. So now can we divide this? Yes, what is 4 divided by 2? 2, so that b to the 2nd, cross this one out. What's the only one we cannot divide? B to the 1st, so this ends up being b to the 1st. Let's do another one, example 8q. 8q. Square root 25 x to the 9th y to the 8th. Go. See how you do with that one. Okay, here we go. Square root of 25 is 5. Cross this one out. Can I divide x to the 9th? No. So therefore I need to rewrite it x to the 8th and x to the 1 with my exponent of 2. So I cross this one out. So now what is x to the 8th divided by 2? That's x to the 4th. And I leave the x to the 1st inside. How about 8 divided by 2? 4, so that's y to the 4th. And we're done. Now some of you wrote the y to the 4th at the end. Make sure you keep them together and the radical is at the end. Hands if you got that by yourself. Okay? Let's move on, number 9. Simplify all variables representing non-negative numbers. So, when you get to this one, draw a line down like this and put a multiplication sign. Here we have, once again, 2 expressions. So, let's distribute first this exponent. What is 8 times 2? 16. That's a to the 16th. What is 8 times 1? 8, and it's over 2. What is 8 over 2? 4. So this is b to the 4th. Are we there so far? We're done with this one. Now let's move to this one. What happens to the exponents with the index? Divide. Is that correct? 3 divided by 3 is b to the 1st. So, aren't we multiplying here? Yes, these are the same base. What happens to the exponents? We add, so this is b to the 5th, and bring down the a to the 16th. And we're done. How are we doing? Okay, let's do another one, example 9q. Copy this one. A squared b 1/2 to the 6th power and 12th root of b 12th. So you got 20 seconds. Okay, let's see. For this one, you draw a line down, put a multiplication sign, yes. Distribute the 6, this becomes a to the 12th, b to the 3rd. Hands if you got that so far. Okay? From there we divide these, that becomes b to the 1st, therefore this is b to the 4th, bring down the a to the 12th, and we're done. So far we're good? Alright, let's move on to number 10. Write the polynomial in standard form, give the leading coefficient, and classify the polynomial. Here we go. For this one, you're going to circle each term. Circle the first term. Does it have an exponent on the variable? No. This is 0 degree. Next term. What is the degree on this term because of the exponent of the variable? 2. And this one is 1 because the exponent on the variable is 1. So far so good? Now let's organize this from highest degree to lowest degree. Highest degree is 2. So what is my term? 12x squared. So we're done with this one. From there we move on to this one, minus 6x. And then at the end, plus 6. And that is what we call what? Standard form. Leading coefficient is the first number multiplying the variable on the first term, which is 12. Guys, focus please. Alright, here we go. So now let's classify this. What is the highest degree? 2, so this is a quadratic. How many terms? 1, 2, 3. This is a trinomial. Once again, in regards to degree, if it's 0 degree, the highest is 0, this is a constant. If it's to the first degree, it's linear. If it's to the second degree, quadratic. If it's to the third degree, cubic. If it's to the fourth degree, quartic. And if it's to the fifth degree, is quintic. And anything after that, it's sixth, seventh, eighth, and so on and so forth. Yes? So this is according to degree. How about according to term? According to term, the first term is monomial. Second term is binomial. And third is trinomial. Anything after that is a what? Polynomial. Alright, let's move on. Number 11. For number 11, it says subtract. Subtract. When we get to subtraction, first we're going to check this parentheses. Is there a negative sign in front of this? No, if there isn't, we're going to rewrite whatever's inside. 9b4 minus b. If the second parenthesis has a negative sign, that means this negative sign is going to change everything inside to its opposite. If this is a positive b4, it changes to a negative b4. We no longer write this anymore. This one is a positive 3b, it changes to negative 3b. This one changes to a positive 3. Let's combine like terms. Here we go. 9b to the fourth minus 1b to the fourth, that becomes 8b to the fourth. Since we're not multiplying, we're no longer doing anything to the exponent. So notice that the exponent stays the same. Okay? Next, negative 1b and negative 3b. That becomes negative 4b. Then at the end, plus 3. Any questions for these? Very simple. Let's move on. Number 12. Multiply. Here we go. Once we get to multiplication of polynomials, most of them are going to, you can actually multiply using the area model. So, when we get to this one, this is what I want you to do. Underneath here, I want you to draw an area model, like so. Draw a line down the plus sign. So now we know that we have how many terms? 1, 2. Do you guys see that? All right? Now, inside of the parentheses, when you see something without a coefficient, I want you to write the coefficient. This is negative 1, and this is positive 1. Because right now we're going to be multiplying, and some of you are going to get lost with that. This one we write here on the side. Negative 8x to the fifth, y to the fifth. So, basically we're doing distributive property. I'm going to multiply this one times the first term. So, what is negative 8 times negative 1? positive 8. X to the 5th times x to the 5th. Since we're multiplying, we're adding the exponents. So this is x to the 10th. Next, y to the 5th and y to the 4th. Once again, since we're multiplying, we're adding the exponents. This is y to the 9th. Are we there so far? Next, negative 8 times positive 1, that's negative 8. X to the 5th and x to the 3rd, that's x to the 8th. Y to the 5th and y to the 4th becomes y to the 9th. And we're done. We don't do anything else with that. All you have to do is write it out. 8x to the 10th, y to the 9th, minus 8x to the 8th, y to the 9th, and you box your answer. Why can't we combine anymore? Because they have to have, each term, they have to have the same exact exponents on the variables. Do the x's have the same exponents? No, that's why we cannot combine. Do another one of these on your scratch paper, example number 12Q. 12Q. Negative 7a to the 4th, b to the 3rd, times, okay, negative a cubed, b squared, minus a squared, b to the 5th. Do that one by yourself. Go. Here we go. First thing you should have done, you drew your area model underneath. Is that correct? You wrote exponent, you divided this into 2 like this, and you wrote your coefficients. Is that correct? You rewrote this one down here, and then we distribute. So what is this times the first term? Negative 7 times negative 1, that's 7. A to the 4th and a to the 3rd, that's a to the 7th. B to the 3rd and b to the 2nd, that's b to the 5th. Then we do the same thing to the second term. This is positive 7, negative 7 and negative times negative 1 is positive 7. A to the 4th and a to the 2nd, that's a to the 6th. And b to the 8th. Yes? What's that? How can we add a 7? Why can't we combine these two? Because they need to have the same exact variables with the same exact exponents. So, do both of these have a and b? Yes. Do both of these have 7 and 5, 7 and 5? No. That's why we cannot combine them. So at the end, we just write 7a to the 7th, b to the 5th, plus 7a to the 6th, b to the 8th. Hands if you got that by yourself. Okay, let's move on. Number 13. All right, if you notice on this one, look up please. If you notice on this one, we have 3 different parentheses. Yes? So it still indicates multiplication. The only thing on this one, we cannot use the area model just like this. But this one we can actually multiply very simply, like focusing numbers times numbers, variables times variables. So let's see. Here we have one number, which is 1/5. Is there another number? Right here. So therefore I'm going to focus on these two. So that's the first thing we do. 1/5 times 20. And if we have that, we write this over 1. Is that correct? So this becomes 20 over 5, which becomes 4. So I'm done with numbers. Next, I'm going to focus on the variables. Here's the first variable, p, and since we're multiplying, I look for the other one, we're going to add the exponent. So this is p, we got 2 plus 3, that is 5. Next one, y third times y third, we add the exponents, so that becomes y to the 6th. S to the 4th, S to the 2nd, we add the exponents, and that is S to the 6th. Hands if you got that. Okay? One more of these or we're good? Okay, let's move on. Let's go to number 14. Okay. For this one, look up, please. For this one, some of you know what to do, you just don't follow directions. It says, use distributive property. That's one thing. Put a little 1 so that you know that's one thing. But what is the second thing? And the area model. That's the second thing you need to do. Some of you totally skip that. So, we need to do those two. Underneath where it says area model, I want you to draw an area model. There it is. Let me zoom out so you can see what it looks like. There it is. So, second thing, look up. We need to rewrite this. This is saying we rewrite this twice. So that is 8m minus 8 times 8m minus 8, which means I write 8m minus 8, draw your line down, and 8m minus 8. And notice that I wrote the 8 next to, the negative next to the 8, like so. Alright, let's distribute. 8m times 8m, 8 times 8, that's 64, m times m, that's m squared. 8 times negative 8, that's negative 64, and we carry the n. I know these should be automatic by now, right? Okay, next. I need to focus on this one. Negative 8 times 8m, that's negative 64m. Negative 8 times negative 8, that's positive 64. And at this point, we start with this one. You circle that and we write 64m squared. You draw the peanut. Remember when I gave you guys that shortcut like this? So since they have the same variable, we just combine the coefficients. Negative 64, negative 64, that's negative 128. And then we bring down the plus 64. And we're done with this one. Alright? Yes? When we're using the area model with binomial, no, it's like that. Always. Alright. So now let's use, we're done with this one. We're done with this one. Now we need to focus on which one? Distributive property. So, sorry. Here we go. Circle this one, and then you need to show me with arrows. Because if you don't, that tells me that you're not following the process. What is 8 times 8? That's 64. M times m, that's m squared. 8 times negative 8, that's negative 64m. Next, I'm going to box this one, and I'm going like this. Negative 8 times negative 8 times 8m, that's negative 64m. Negative 8 times negative 8, that's positive 64. At that point, can I combine like terms? Yes, these two right here, that's negative 128m. Bring down the 64m squared, and plus 64. Is that the same that we got over here? Yes, you should. How we doing? Another one of those, or what? Okay, another one of those. Example, back. 14 cubed. Copy this one. 14 cubed. Parentheses, 3m minus 3, close parentheses, squared. Do that using distributive property and the area model. Go. Okay. Your product for this, you should have gotten 9m squared negative 18m plus 9. Hands if you got that. Okay. Once again, two different ways, right? Distributive property and area model. Go to number 15. It says a rectangular garden. What does that mean? Draw a rectangle. Bah. So draw a rectangle for this one like so. So let's read the instructions. Look up. It says, a rectangular garden with length 4 times its width. Length 4 times its width. This is the width, this is the length. The length is 4 times this. Do we know what this measures? Do we know what this measures? Do we know what this measures? No, therefore we label it X. So now, if this is 4 times this, what can we label this? 4x. But then it says that it's to be expanded both sides, which are increased by, what is increased by 6? Plus 6, plus 6. Does this look familiar? Yes. We find our area. What is x times 4x? That's 4x squared. What is x times 6? That's 6x. What is 6 times 4x? That's 24x. What is 6 times 6? That's 36. And here goes, Taylor C. Let's see if it works. This one, we write it first right here, 4x squared. You draw your peanut right here. It's x. What is 24 plus 6? That is 30, and it's a positive. And we bring down the plus 36. However, are we done? No, it says which expression models the area. That means you need to write area equals. And we're done. So far so good? Okay. Let's go to number 16. Or do we need to do another one of these? Number 16. Okay, this one. This one I was about to smack someone, my goodness. This one is the simplest one, and you guys forgot to do the second part. You guys don't read directions. Bah. Here we go. Look up, please. For this one, if you notice, if I was to get rid of this bottom part, do we know how to solve this equation? Yes, but what's in the way? The divided by 2. How can we cancel the division by 2? Everyone, multiply times 2 to both sides. So we end up with 9x plus 4 equals 58. And from there, you know what to do. Subtract 4 from each side. 9x equals 54. And at the end, we divide by 9. X equals 6. Am I done? No, because it says to check your answer. So you're going to write check. 9x plus 4 over 2 equals 28. And now we're going to substitute the value of 6 in here. So that becomes 9 open for, I'm sorry? 29? Oh yeah, I did that on purpose to see if you're paying attention. Be nice. Plus 4 over 2 equals 28. And that goes in here, this is 6. Oh, 29, my bad. Alright, here we go. So what is 9 times 6? 54 plus 4 divided by 2. What is 54 plus 4? 58 divided by 2. What is 58 divided by 2? 29. Is 29 the same as 29? Yes. That's how you check your work. Make sure you read your instructions thoroughly, please. Yes? Okay. Number 17. Or do we know, do you want to do another one of these? Okay, 17. We move up a little bit. There it is. Number 17. Okay, look up please. Do I need to zoom in or are you guys alright? Okay, let me zoom in. Alright, it says solve and name the properties used. This one's another one that a lot of you missed because you forgot the second part. So we go, let's solve this. Since we have fractions all over the place, we need to get this simplified so that we don't have fractions, which means we need to multiply the entire equation times the LCD, least common denominator. So let's see. We got 3 and 4. What would be a common denominator between 3 and 4? 12. But then we have 5. What would be 60? 60 is our LCD. So, we multiply the entire equation times 60, but we only multiply the numerators. Tell your neighbor what I just said. So, what is 60 times 2? That's 120 over 3. That's Z. Okay? Minus 60 times 3, that's 180 divided by 4 equals 60 times 4, that's 240 divided by 5 plus 60 times 3, that's 180 divided by 4, and that's Z. Okay, let's simplify this. 120 divided by 3, that's 40Z minus 180 divided by 4, that's, what is it? 45 equals 240 divided by 5, that's 48. Yeah, I was testing this. 48 plus 180 divided by 4 is 45Z. Alright? Do we know what to do from there? Get all variables to one side. What is my smallest variable? 40. So we subtract 40Z to each side. This is negative 45 equals 48 plus 5Z. From there, we need to get rid of the 48 because we need to isolate the Z, right? So we subtract 48, subtract 48. So we end up with negative 93 equals 5Z. What's our last step? Divide by 5, divide by 5. We end up with, let's see, let me scoot up a little bit. Z on this side, it's a negative. 5 fits into 9 how many times? 1. We have 4 left over. 5 fits into 43 how many times? 8. And how many left over? 3. You can leave it as 3/5 or negative 18.6 equals z. Either one. Another one of these or continue? Okay, let's go to number 18. Yes. Oh, the properties. Bam. Here we go. Focus, please. So it says, what did we do here when we multiply times the LCD? Distributive property. Didn't we distribute? Yes, right? Next. From here we simplified. That's not a property. However, what did we do here to each side of the equation? Subtracted. So therefore this is subtraction property of equality. What did we do here to each side? Subtracted, so it's already there. It's fine if you only write it once. But what did we do here at the end? Divided, so then you write division property of equality. Let's see if we got all our properties down. Distributive property, subtraction property of equality, and division property of equality. And we're done now. Alright. Let's go to number 18. Look at this one. Solve, and what else? Name the properties. First of all, let's see. We need to get rid of parentheses, right? So that means we're going to distribute in here. So what is negative 8 times negative 11? That's 88u. Negative 8 times a positive, that's negative. 8 times 8, that's 64. I got 6. 32, that's 38. Equals. We do the same over here. That's positive 360u minus 1200. Let's write the property, might as well since we're already there. What is this property that we did? Distributive property. Alright, let's continue. What do we do next? Get all variables to one side. What's my smallest variable? 88, so we subtract 88u from each side. These cancel, we're left with negative 384 equals 360 minus 88, that's 272u. Bring down the negative 1200. So we need to leave the u by itself. That means we need to get rid of this 1200. So I add 1200 to each side. We're left with 1200 minus 384. That's 8. What? 16? Yes, Mr. Q. All right, good. 272u. And what's our last step? Oh, hold on. Before I continue, what did we do to each side here after we distributed? So you write subtraction property of equality. What do we do here? No, we already subtracted. What do we do here? Add addition property of equality. So here, the last step, we're going to divide by 272. So 816 divided by 272, is that 3? Is that 3? That is correct, and this is division property of equality. How are we doing? Another one of these? Go to number 19. It says, solve and name the properties. Again. Now be careful with this one. Look up, please. Guys, focus. Look at this one. This is the one that a lot of you made simple mistakes. And let me show you the mistakes that you guys made. Here it goes. So, solve and name the property. So I'm going to draw my line down. And the first thing we do, let me pause this for a little bit. First thing we do is combine like terms. Is that correct? Since there are no parentheses, we combine this one with this one. I bring down the negative 13g. And negative 2 plus 5, that's positive 3. And I combine this side, negative 5g and negative 8g, that's negative 13g minus 7. Are we there so far? So, some of you wrote on your steps, combine like terms. However, this is asking for what? Is this a property? No. What properties are used when we combine like terms? The first one is commutative property of addition. And then the next one, when we group stuff, is associative property of addition. Those are the two properties used when combining like terms. Once again, when we combine like terms, what properties do we use? Commutative and associative properties. When we combine like terms, what are the properties? Commutative and associative. When we combine like terms, what are the properties? When we combine like terms, what are the properties, Juliana? When we combine like terms, what are the properties, Zoe? Commutative and associative. Don't forget that, please. So let's continue. Okay, look up, please. So what would be the next step? Get all variables to one side. So I need to add 13g, add 13g. This cancels, we're left with negative 7 equals, wait a minute, this cancels and we're left with 3. Is this true? If it's not true, it's no solution. What if we did have negative 7 equal to negative 7? What would that be? All real numbers. Remember that? Okay. Continue, number 20. It says, the fuel for a chainsaw is a mix of oil and gasoline. What kind of stuff? Oil and gasoline. Oil and gasoline. What is the first one that they mentioned? Oil. What is the second? Gasoline. Oil and gasoline. Oil and gasoline. The first one that they mentioned is oil. The second one is gasoline. Why is that so important? Because when they give us the ratio, these two numbers, the first number corresponds to the first one that they mentioned, which is oil. The second number corresponds to what? The gasoline. So therefore we need to write a fraction, 3 over 11, and write our proportion. So they're saying there are 22 gallons of gasoline. Which one of these numbers corresponds to gasoline? The bottom, so that means we need to write the 22 down here. And to solve for the ounces, we need to write x. And who remembers these? Cross multiply, right? X times 11, that's 11x, equals 3 times 22, that's 66. And then we solve for x, which is divide by 11. X equals 6 ounces. That's it. Pretty simple? Let's do one more of these, please. Do this one by yourself on your scratch paper. Now, I don't know why some of you missed this one. It was so simple. It says, the fuel for a chainsaw is a mix of oil and gasoline. The ratio that they give us is 7 to 10, and there are 30 gallons of gasoline. Do that one by yourself. Go. Okay, who got 21 ounces? That is incorrect. Who got X equals 21 ounces? Okay. Let's continue. Number 21. It says, what percent of 33 is 72? But notice the last part. Round your answer to the nearest tenth. To the nearest tenth. Therefore, since they're asking for a percent, that means we're going to write our proportion is over of equals percent over 100. From there we rewrite this, but with blanks. Blank over blank equals blank over 100. So let's see, what information do they give us? What is the of? 33, it goes down here. What is the is? 72, it goes up here. And since they don't give us a percent, that becomes x. So we need to solve for x. So this is 33x equals 7,200. Therefore, we need to divide by 33 both sides. X equals, and let's do our division. By the way, since they're asking for a percent, make sure you write somewhere percent in a blank, because if you don't write percent, you get points taken off at the end for the answer. So let's see, 72 divided by 33. 33 fits in there how many times? Twice, that's 66. 6, bring down the 0, fits in there once. 33, subtract, that's 27. Bring down the 0, fits in there how many times? 8. 24, we got 2, 24, that's 26, subtract, that's 6, add a decimal, and a 0, bring that down, let me move this up, fits in there once, subtract, 33, sorry, subtract, that's 27, is it going to repeat? So that means the next one is 8, and the next one is 1, and the next one is 8. But they want us to round to the nearest tenth. Which is the tenth? It's not the 8th, it's the 1. So what does this become? A 2. So my percent is 218.2%. Yes? Questions, comments, autographs? Okay. So, I'm going to stop right there, and we're going to take a little break.